So what I want to do is to go over a couple of questions that people had about parabolas and do a bit of a review on parabolas. So I'm going to start out, and I'm going to start out with we'll talk first about the equation for a parabola, and then kind of branch off into some questions about the parabola. Okay, so a parabola is of the form either 4p times y minus h, or excuse me, y minus k equals x minus h squared, or it's going to be 4p times x minus h equals y minus k squared. Okay, so this one is in the case of what we say is going to be parallel to the um, y-axis, or in this case, this one here is going to be parallel to the y-axis. So basically, this one here has an axis of symmetry that is vertical, and this one's axis of symmetry is horizontal. And how can you tell? Well, the way that you can tell is that this one has the y value squared. So this one, that y minus k is the thing that's just squared, and so that tells me that it's going to end up being horizontal, right? We might call this a left-right one. So if you want to think about it, it kind of looks like this, okay? On the other hand, this one has the x value squared. This is the one that's probably the one you've seen more often, and this is going to be what we might call the up-down one, and hence its axis of symmetry is going to be vertical, okay? So those are some different ways to kind of think about, all right, well, I've got these two different equations, and the first thing I want to know is, is it, is it going to be vertical or is it going to be a horizontal parabola? Okay. Okay. So now that I've done that, I now want to talk a little bit like kind of generally about those equations. And let's just talk for generalization purposes about this equation. Let's call it 4p times y minus k equals x minus h squared. The first thing that I want to get is the vertex, right? And so we've got the vertex, and that's going to be hk, right? And that's this little part right here, right? Okay. It's the either the lowest or the highest part of the parabola in this case, or in the case of the horizontal ones, it's going to be the farthest left, farthest right point. Okay, and that's the first thing because it's kind of like the starting point for our parabola. Okay, now the next piece, so we've got there's the h, okay, and there's the k. It gives me one point that I can actually graph. Okay, the next piece here that's important is this thing called p, and p is the distance from the vertex to a point called the focus, or the distance, perpendicular distance, what we call it. So the straight line distance from the vertex to the directrix. Okay. And so for our purposes, really, those are the things that we kind of want to think about or we want to kind of like focus on. All right. Part of the pun. So let's take a look and let's talk about this thing. Let's say, for example, suppose the vertex, and by the way, this is 7.3, number 2. Okay. Suppose the vertex of a parabola is 2, 6, and its focus is 215. So what I'm going to do is I'm actually going to kind of set this up. on a graph, and then we're going to talk about it, and we're going to kind of, rather than think about it in equations, we'll think about it mostly as a graph, but then also somewhat as equations. So I've got this thing here, right? Let me draw my graph. Okay. So my vertex is going to be at 1, 2, 1, 2, 3, 4, 5, 6. And my focus is going to be at 7, 8, 9, 10, 11, 12, 13, 14, 15, right? We'll be up here, okay? So there that is, right? So here's my focus, and here's my directrix. Not my directrix, excuse me, and my vertex. Now what we said is P is the length from the focus to the directrix, to the vertex, excuse me. So, well, I do actually know what that is. That's 15 minus 9, right? It's 15 minus 9. So P equals 9. P equals 15 minus 6, excuse me. So P equals 9. And there we go. Now, I'm going to look at my equation. I don't even need to really even draw the picture. I just need those two pieces of information. And so now my equation is going to be 4 times P, so 4 times 9, times Y minus K. Okay, so Y minus, in this case, K is 6, equals X minus 2 squared. And there it is. There's my equation. So all I really need in order to get that equation is I'm going to need the equation for the vertex, right? Here's my K, here's my H, okay? And then I'm going to need to find P, but the easiest way to think about P is just the distance from the focus to the directrix. Excuse me, from the vertex to the focus. Okay? And if you just notice, right, in this case, the x values, because it's up down, are going to remain exactly the same. And what we'll do is we just need to subtract the y values. So you're subtracting the y values. Okay? So that's one way to kind of like utilize the information that we have about a parabola in order to construct the equation of the parabola. Kind of from the graph, really. Now, what about if we're given something like what's in the journal? So let's say, for example, that I'm given that 16 times y minus 1 equals x minus 6 squared. Okay? And it asks us for things like the vertex, the focus, the directrix, the focal diameter. Okay? So we're asked for all these things. And the axis of symmetry. Well, one of the ways that I might go about doing this, for me, it's always easiest for me to think about it graphing wise because it's easier to deal with graphing than it is to deal with our equations. So let's imagine that I've got this equation, okay? All right? And I know, the first thing that I know is that in this form, right? Okay, so the standard form is 4p times y minus 1 equals x minus 6 squared. Okay? So the first thing that I'm going to do is I'm going to notice, or excuse me, x minus k, y minus k times x minus h. So h equals 6 and y equals 1. Take that directly from the equation. Okay? That means that my vertex, right, is going to be 6, 1. Yep, 6, 1. So I'll do that. 1, 2, 3, 4, 5, 6. There it is, 6, 1. Okay. Now the next thing that I need to know is that my focus, right, is the distance from, excuse me, the focus is like p distance away from my vertex. Okay. One thing to note actually is this one's going to be an up-down, right? So it's going to be facing upward. So if I kind of want to think about it, I'll think about it like along these lines. Okay. So how do I find that? Well, I know that this thing here is going to be, well, p above, in this case, my vertex. So 4p is going to equal 16, and so p will end up equaling 4. Okay, just do a little algebra. And so what that gives me is that it's going to be 1, 2, 3, 4, 5, 4, excuse me. 1, 2, 3, 4. Okay, and so there's my focus. Okay, there's my focus. And if I look, what's that point? That point is 6, 5. Okay, so my focus is going to end up being 6, 5. My directrix, by definition, is the same distance is the line. So this is my directrix. The directrix is the line that is the same distance away from the vertex as the focus, but in the opposite direction. So what I'm going to do with that is I knew that the focus was 4 above my line. Okay, so what that means is that the directrix is going to be 4 below it. So that's 1, 2, 3, 4. So that's at -3, and it's going to be this line right here. Okay, so there's my directrix. Okay, so my directrix ends up being the line y equals -3. Okay, now my focal diameter. Okay, the focal diameter is the length of the line, okay, from the focal diameter is the length of the line from one side of the parabola to the other through the focus. So, I mean, I can draw a picture of that. Okay, it's going to be a little tricky in order to be able to do that. I can draw my picture, but that's actually not going to give me an exact answer. So what I'm going to need to do is I'm going to need to plug in. So notice that the focus, right, is up here at, right, y equals 5. So I'm going to have to plug in y equals 5 into my equation and see what I get back, and then find the distance between those two. So if you remember my equation again, it's going to be 16 times y minus 1 equal to x minus 6 squared. Okay, so there's my focal diameter. Okay, and so hence I'm going to plug in 5 for y. So it'll be 5 minus 1 is equal to x minus 6 squared. So this thing here, this is going to end up being 64 equals x minus 6 squared. Okay, now we need 2 points for this, but the good news here is that when I take the square root of both sides, I'm going to end up with 8 equals, or plus or minus 8, excuse me, equals x minus 6. Right? Don't forget that plus or minus, otherwise you're going to only end up with 1 point, and you're not going to actually be able to find a focal diameter. So now, I'm going to move this right up here. That's going to be, I'll have first 8 equals x minus 6. So that gives me x equals 14. Okay, Okay, and negative 8 equals x minus 6, and that'll give me x equals negative 2. Okay, now what I get from that is that these are the x values, okay, for the focal diameter, right? So basically from here to here, that's the focal diameter. So that's going to end up equaling 16. Okay. Focal diameter ends up equaling 16. Oh my, is that merely a coincidence that that actually ended up being the 4p? No, it's not. Okay, it turns out that the focal diameter so the focal diameter always ends up being 4p. Right. So let's take a look at, by the way, that the focal diameter then allows us to actually complete the drawing of the sketching of our parabola. Okay. So what we do is we say, okay, so I'm going to end up with, this is going to end up at negative 2. Okay. And since the parabola is symmetric, we know that I'm going to basically end up over here at 14 as well. Okay. So I know that right here I've got one at um, 5, negative 2, and also another one at 5, 14. Okay. So, I mean, that's basically one of the ways to kind of think about this. Now, from the perspective of your equation, if you're looking through and you're like, okay, so how do I relate this to my equation? Well, what's going to happen here is, let's just talk about this from an equation standpoint. We have 4p times y minus 8k equals x minus h squared. Okay? So the first thing that I want to do is I want to figure out what h and k are. So h and k, they're the vertex. Okay? Then I want to find p. Okay? So 4p is the focal diameter. You kind of figure that out pretty quickly. All right? P is the distance from the vertex to the focus. And it's, in this case, it's directly above the vertex. Okay? So it's going to have the same h value. All right? So here's my focus. It's going to have the same h value because it's going to have basically the same place on the x-axis, and then it'll end up being k plus p. So we add k plus p. In the case of the directrix, okay, the directrix is going to be y equals k minus p because it's in the opposite direction. Okay. By the way, this is all for up down. Left right, you're just going to switch which of these you're going to use. Instead of using k, you'll use h. Okay. So this is our directrix. So we've got our vertex, focal diameter, focus, directrix. Oh, and the last piece that we want is the axis of symmetry. So let's go back up. Let's look at our graph again. The axis of symmetry is this line here that goes through the vertex and the focus and cuts the parabola in half. And so if all we need there is that's going to end up being x equals h in this case, which is x equals 6. So axis of symmetry will be x equals h. Okay? Let's actually take a look at like the right left one, and then we can do those ones and just give our equivalents here. So we have 4p, and this one's now going to be x minus h equals y minus k squared. Okay? The vertex, again, is going to be hk. Four p will also be the focal diameter. So here's our focal diameter. It's 4p. Okay? P is still the distance from the vertex to the focus. And so the focus, this time, though, is going to have the k remain the same, and it'll be h plus p. Okay? Right? And then the directrix is going to be y equals h minus p. So notice that we change from the k to the h. Okay, and that's how it works graphically, because now our x values, okay, are the things that are changing, and our y values are the ones that are kind of remaining symmetric. And then finally, our axis of symmetry is going to be a y. Oh, excuse me, directrix is x equals h minus p. Sorry, we switched that around. My axis of symmetry is going to end up being y equals k. Okay, so that should help you to kind of review these problems. Now, if you go in and you redo some of the homework on these, it'll help you to kind of like move through and get used to utilizing the equations. I would definitely suggest that you do some of them, right? And then continue to study and see if you can like do these relatively short homework assignments without utilizing your notes as preparation for your exam. Okay? I hope that helps.